All right, engine performance 1 test 16, technician A says the fuel pump relay is controlled by the PCM. Technician B says some fuel pump assemblies use a spring to ensure correct position of the pump. That's both of them, yeah. That's right. And what do they mean when they say they use a spring to ensure the correct position of the pump?
Those little columns, those springs.
That's right. When you put it down in there, it crams the pump all the way down to the bottom of the tank. Now, you remember you hear me talking about that before? There was a time whenever the gas tank sending unit would go on the top of the tank and it would have the fuel pump on it, or maybe if it was just had a pickup and a fuel pump out there. The fuel pump will be right here. And hey, Sharon, the fuel pump would be right there, and that fuel pump pickup would be right off the bottom of the tank, about an inch or so. It wouldn't be on the bottom of the tank, but what happens then is, as condensation happens whenever people are running with low gas, it'll start building water up in there, and you'd wind up with a gallon of water sloshing around to the bottom of the tank. That's bad. But if you put the thing right on the bottom of the tank, where it's touching the bottom of the tank and it's drawing right off the bottom, before very much water gets in there, it gets dealt with. You know, it gets pulled up before it gets too much in there. Okay, we got all kinds of stuff here to do, don't we? Now, which vehicle is this for? I'm assuming that's for that Crown Victoria.
One's 530, one's 51030, I think.
Well,
It don't say on here.
well, that was a second-rate amateur thing to do.
This one has the valve cover gasket with it.
That's good. Yeah, there you go. That's the Mazda. Okay, Judy. All right. I'm going to prevail on you to put these on my desk for me. The ones that are copy. And this one right here is for the Crown Vicky.
You got me a tip.
Yeah, buy low, sell high. There you go. Oh, by the way, there's a thermostat out there in that bag, and I need Brett to take that back because it turns out I'm not going to need it. So I can carry it back to him. Right by that antifreeze. I think you brought it earlier.
Yeah, just the thermostat and the gasket.
Yeah. Yeah, just take those two back, but leave the antifreeze here because I gotta have it. And put those on my desk. All right, and buy low and sell high. Well, anyway, that's what I was gonna do. They have a little pickup about that high off the ground. I mean, off the bottom of the gas tank, and that water would be sloshing around in here and everywhere down there. When you got enough water in there, you go to make a turn, and it slosh up here and pick up some water, and the engine go poof, go down like that. So you basically want to get rid of the water before there gets to be too much in there. Right? That's what the long and the short of that is. And they make it, if you ever see them do that, a lot of times they'll have this little circular thing, it's got these little pegs on it, like this right here, and it's pulling the fuel up like that, and it's sitting right on the bottom of the tank. And they call these little things nibs. And it creates a vortex when it's pulling the fuel into where it's vacuuming the bottom of the tank. Really good. I mean, it's keeping the tank clean. It's really interesting how those engineers come up with that stuff. You know, you would never think about it if you were just a plain old guy like you and me. Okay, let me see. Technician A says fuel filters are located in the fuel supply line. Technician B says fuel filters are located in the fuel return line. Who is correct? Now, the fuel filters are going to be in the supply line. They're not going to have them in a fuel return line. All right. The following statements are correct except inline fuel filters may be installed in either direction. You're really not supposed to put them on backwards, you know, because they'll stop up quicker and all that if you do. Which way does that fuel go through there, by the way? Oh, please. He just points his finger like I'm supposed to be able to tell it.
Back to front.
Back to front, yeah, but I mean, like inside the filter. All right, you got a line here, and you got a line here. And you got an arrow on there like that, right? That's why I was wanting to tell you that. So, what's inside that filter? It's not just a screen. It's basically going to have some. It's basically got a little cup in here, cupped filter. It looks like it's fluted, like like you've seen an air filter. And just drawing a cross section of it. And usually it'll have a spring like that. And so what happens here is, wait a minute, I drew that backwards. Ha. The fuel is actually going this way. And it comes through the outside of this and it comes out here. See that? It comes around, it washes around the outside, it has to pass through that, and then it goes out that end. And the reason you got more area out here, you got it? That makes sense? Now what if you turn it around? It's not gonna take near as long for this inside to fill up and clog up as it is the outside. Because if you look at the filter, the way it's designed, if you got the inside and the outside, see that? See, it looks like that. And so this trash can actually also be stopped and get down in here in between these. But on the inside, you know, you ain't got, it just clogs up really fast. That makes sense? I mean, ever describe it to you before? All right, there you go. All right, now then, let's look and see. Fuel pump may be able to, all these, excuse me, that was all of these are, statements are correct except, and let's just read the ones that are correct. The fuel pump may be able to create good fuel pressure but inadequate volume. You ever see that? How do you determine that's a problem? Remember, have you ever seen me pull a fuel, and you've probably done this, you pull a vacuum line off the fuel pressure regulator and the fuel pump, the fuel pressure jumps up 10 pounds if it's a return line system? All right, this is what you're gonna do. Somebody comes in here and says, I don't got no power. You pull that thing off, you put your fuel pressure gauge on it to begin with, you pull your line off, and you're gonna watch that fuel pressure bounce up to 40 pounds. And then you're gonna snap the accelerator to the floor really hard. Boom! Now you're not gonna let it, you know, thunder, you're just gonna snap it real quick. And when you snap it, that fuel pressure ought to stay rock steady. If you snap it and the fuel pressure drops and then comes back, then you know that you got either one of two things. You got a clogged up fuel filter or you got a weak fuel pump. Got me? Real easy to diagnose. Not a problem. That's a precise diagnosis. If you see that, your diagnosis is done until you correct that. You know what I mean? Some people, if you tell somebody, if you snap the throttle and the fuel pressure drops and you say, well, it's going to be $215 for a fuel pump, 2 hours labor to change it, you know, and your bill's, you know, going to wind up being like $385 or something like that. They say, well, golly, that's a lot. Can't we look for somewhere else for the problem? Yeah.
I got the same problem with my truck. Give it some gas and just, everything I
Yeah, well, I mean, check the pressure. That's where I would go. The first thing I'm gonna,
had. This throttle body,
you still got fuel pressure on it, and the fuel pressure can be bad. Throttle body injection is supposed to have 12 pounds on them Chevy trucks, like you got. You got a Chevy truck, right?
yeah.
You put a throttle. We can check the fuel pressure on that thing, and if those doggone things, a lot of times will feel like somebody's put a potato in the exhaust pipe. And if you got low pressure, it'll do that. And you'll have to have a pump or a filter. If you pull a filter off first and see if you can blow through it, you know, because the filters stop up on them things all the time. And the first place I'd go is a filter, do what's cheap and easy first. You know, it's the smartest thing to do. Okay, now then, sometimes, and here's another thing, sometimes somebody will say, when I drive on a long trip, and I'll be in the hot summertime, then I'll get to where I'm losing power, and I'll finally quit. And then it won't start for a while, or it'll start and then it'll go a little bit till it cools off. You go, George. You okay better? You're not sick no more? All right then. All right, we'll find you a YouTube channel and see if you can punch in there. You got all your tests done?
No,
You did some of them at home or something?
Yes.
Okay. All right then. Well, we got lots of hard work for you to do today. You can get your hands dirty before you leave, so you're good. All right. Now then, but what they say is, this is what I'm gonna say. I said, you put a fuel pressure gauge on that one, and you park it somewhere where it's out of the way, and you crank it up and you let it idle. And you do other work. You're not gonna stand there watching it the whole time. And you walk by it every now and then, and you listen to it, and you look at the gauge, and walk by it, and listen to it, and look at the gauge. If you let it run, sometimes you may have to run like 5-6 hours in the shop. You walk by there, next thing you know, you see it's dead, and the fuel pressure's gone. You start it up, fuel pressure comes back, then you'll see it falling back off. Seen that all the time. I mean, lots of times I've seen that. But you have to be patient and do other work while this is happening. You know, it's not cost effective to stand here with your arms folded or talking to your buddy or shooting a bull for 5 or 6 hours. You need to be going ahead and doing that tune-up and doing this other work and, you know, throwing some brakes on something and doing other jobs while this one's running. You know, you got to work smart. And a guy that works smart, that makes a lot of money, he'll have 3 or 4 cars going at the same time. You know, in your mind, you're thinking, I'd like to finish this one and then get the next one, finish this one. No, sir. You start on this one. They say, hey, they'll say, Cameron Webb, come to the right up area. So you go up there, yeah, can you stop what you're working on, do this, and this guy's waiting on this one. You know, yeah, I guess so. So you go out here and you start on that, and then they call you again. The part came in for this other one, and they did it back. You know, well, I got a customer waiting. Well, I don't care. He'll wait a little longer. You need to get this other one out. So you got 3 or 4 going at the same time, or maybe 5. You know what I mean? So it's just what you got to get used to. Get ready for the grind. That's what you got to, and make sure you're at work every day on time. Don't be late. All right, let me see. Inline fuel filters may not be installed anywhere. Fuel injectors may have a built-in filter. They do. Throttle body injection is designed for lower pressure fuel than port fuel injection. That's what we were talking about just now. Yours has 12 pounds of pressure, or it's supposed to have. Technician A says one purpose of gasoline is to cool the fuel injectors. Technician B says many fuel systems have a Schrader valve to test fuel pressure. That is correct, but the Schrader valves are going away on just about everybody's car, and usually you got like on the newest ones, you got a fuel pressure transducer in the fuel line. You can check the fuel pressure with a scan tool, or you can hook a line T in a line between the fuel filter and the and everything else. They just quit putting Schrader valves on them. I don't know why. I don't like it any better than anybody else does.
So is that B?
Huh?
Technician B? Or
Both of them. The following statements are true except A, stuck fuel injectors may cause a drop in fuel pressure after the pump is shut off. Yes, if they're stuck open. B, defective check valve is the only reason fuel pressure might drop after the pump is shut off. So what's a check valve? Where is the check valve? What is a check valve? Check valve's in the pump. The check valve is actually, let me make sure I'm drawing where I can see. The check valve is actually in the pump. Let's say your pump's pumping out this way. There'll be a little spring, and a little ball, and a little seat. And the fuel's coming out this way. And when that fuel pushes against that ball, it unseats. Well, as soon as the fuel pump shuts off, that ball goes against its seat. And it holds fuel pressure on that line. Now, if you've got one that starts hard when it's hot, if somebody's out here, they say, hey, when I park in the parking lot and I come back out here, I start up, and it finally starts up. You say, okay, well, if you turn the key on about 4 times, let it stay on for 2 seconds each time, does it start right up then? Oh, yeah, it does it then. Well, then I'm going to put my fuel pressure gauge on it. I'm going to crank it up. I'm going to shut it off, and I'm going to see if it holds that pressure good and solid. It ought to hold it within like 5 pounds for a couple of 3 minutes. If it drops right back off, and it's going back into the tank past that fuel, that it's going to have a fuel pump for that. Seen that a zillion times. Real common. Okay, that is the one that is the right answer for this, because the defective check valve is not the only reason fuel pressure might drop after the fuel pump is shut off, but it is the most common reason, okay? A defective fuel pressure regulator may cause it, that's right, but all of the statements are not correct. The defective check valve is the only reason. That's the one. B is the right answer for that one. Technician A blocks the return line when diagnosing a loss of fuel pressure. Now, why would he do that? Why would Technician A block the fuel return line when he was diagnosing loss of fuel pressure? Anybody got any ideas? Let me ask you this. Let's say that your pressure falls off really fast, and you block the return line, and it don't. It stays steady. So now what do you know? Does anybody know?
losing pressure on the return?
Yeah, well, where's the pressure going if blocking the return line causes it to hold steady? Well, all right, now what am I going to do to fix that? This is something I hadn't really covered a lot, and I probably should have. Let me get over here. This right here is your fuel pressure regulator, right? Okay, it's on the fuel rail, like this right here, and you've got pressure coming in. Let's say we're just going to make this real simple. You got pressure coming in here, and the pressure coming in here is going to go up in here, and it's going to, there's a little diaphragm and a spring with a seat and all that kind of stuff, and the fuel pressure is going to push that diaphragm up, and it's going to push a little ball off the seat in there, and it'll take whatever this regulator is calibrated for. It'll take like 40 pounds of pressure when there's no vacuum on there to push that diaphragm off the seat. And after it pushes off the seat, where does the excess go? It goes out the return line back to the tank, right? Okay, so but it's designed in such a way so that whenever usually it'll have a port right here, and the fuel will go in here, and then when it opens that up, there'll be a little pipe that's hooked to that one that goes back in. This pressure going in here is going to raise the diaphragm up and unseat that ball. Well, let's say that ball, it gets something trapped under it or whatever, and it winds up so that there's fuel going back all the time. If you stop up the return line, you block it, and you got your return line pulled off right here, and the fuel pressure stays steady because you're checking it right here, see? then you're gonna know that this thing right here is at fault. So the fuel pressure regulator is what's wrong if you block the return line and the pressure stays steady. Got it? If you block the return line and it still bleeds off, it's gonna go one of two other places, and what would those two places be? One would be what? What did I just talk about a minute ago? Am I gonna have to make you guys start reading the book to do these tests? What was I talking about a minute ago? The check valve in the pump is supposed to hold the pressure good and solid in this rail. You got me? All right, that's another place, that's one place it can go. So it can be going back this way, it can be going back that way. If you block this, and if it's still going back, then it can be in here, but it can also be leaking through the injectors. You got several, you got 4 of them on this silly little fuel rail I'm drawing. If it's leaking through the injectors dripping in there, it'll make it start hard for 2 reasons. It'll start boiling the fuel because it doesn't have pressure in there and you'll have air. Or if it's dripping gas in the cylinder, it's going to wet the spark plugs and it's going to make it start hard for that reason. And one dripping fuel injector can wet all the dadgum spark plugs and make the whole car start hard. It'll spin for sometimes 40 seconds before it'll fire up sometimes because of one dripping fuel injector. In some cases, it'll just skip on that one cylinder, but it depends on the dynamics of the way the intake's put together and all that. Okay, technician A, blocks the return lines. There you go. Technician B says if pressure continues to drop after the supply and return lines are blocked, the defective pressure check valve is the problem. Now, what you can do, some of the kits will have a little valve so that you can actually pressure the system up and turn a little valve and block it so that you've trapped pressure in the fuel rail. And if you got fuel pressure trapped in the fuel rail and it's going away, you know the injectors are the problem. Got it? And so that's basically both technicians are right there. Okay, pressure check valves in the fuel pump once again. Technician A says if vacuum is used to control fuel pressure regulator, the regulator should change as the pressure should change as the throttle plates are opened, and that is true. Technician B says on returnless fuel systems, they misspelled that, it says furl systems, pressure should change as the throttle plates are opened. They should not. On one that's a returnless system. However, let me tell you this. Some returnless systems have got a electronic module that basically controls the amount of current going to the pump. So if it increases the amount of current going to the pump, the pressure increases. If it reduces the amount of current going to the pump, the pressure reduces. And so that's the way that some of them work. And on those, you may see a change in fuel pressure when you gas it. So this question here is not absolute. What do we have here with a returnless fuel system on it? What have we worked on? What do you pull up off the top of your head? We got a bunch of trainer cars out there. Now the Bronco's got returnless. That's got one line going to the fuel rail and only one line and no fuel pressure regulator. At least not one on the engine. The Dodge Neon, it's just got that little round pipe with one fuel rail going to it. There's no regulator on that, except back there, you know this big round thing on top of the gas tank, the fuel pump? That is actually a fuel pressure regulator and a filter. And you change the filter every 120,000 miles on those. And that's what the thing is. You ain't got a filter anywhere except right there on that car. All right, so let's see. That's number 8 is A. And number 9, how much fuel should be supplied to the engine every 30 seconds? That's a difficult question, and if you didn't know the answer, it's 2 pints. Well, be careful when you're checking that, though, so you don't set fire to some. Technician A says low power on acceleration is a symptom of a restricted fuel filter. Yeah, that sounds about right, doesn't it? What you got going on over there on your truck? Technician B says loss of high-speed engine performance is a symptom of a restricted fuel filter, and that's right, too, both those guys.
I got both of them.
Both of them, yeah. Number 10. All right. All right, and that is, those 10 questions conclude engine performance 1 test 16. We got one more we got to do.